3. This is lesson 3A, characteristics of quadratics. We have our general outcomes here. We're going to do number 1. We need to analyze quadratics according to all of these different things. Then we've got to sketch our graphs and understand what those parts of our graph mean. Let's see what we have. Quadratics in general form. We're used to seeing this. We've been factoring all kinds of questions like this in this format. Okay, we've been solving equations as long as they equal to 0 last unit. Now we need to actually know, well, what the heck does A, B, and C mean? What do they do for us? Okay, well, first of all, A is a couple things. A tells us up or down. So the one thing it tells us is the direction of the opening. Direction of the opening. Okay, is it going to go up or down? That's the end there. Okay, up or down. Okay, and A also tells us one more thing. Okay, it's got two jobs. It tells us up or down, and it also tells us how narrow or wide it is. So it tells us whether we have a vertical stretch or a vertical stretch or a vertical compression. So we call that wide. If it's a wide or narrow graph. So if it's a wide graph, that's called a vertical compression. And if it's a narrow graph, it's going to be a vertical stretch. Okay? Now hopefully you have a moment or a space there where you can draw a little mini graph of what that actually is. So this is what A does. This is all what A does. I just draw it very big. This is all under A. Okay? That's what A does. So if I've got a graph, this is what it's telling me. The A value of this graph, I could have one that does this. Okay? And I could have one that does this. Okay, those are two different graphs. And that's all based on what the A did to the graph. So here, I have a wide graph. It's opening wide, okay? If it's going to be opening wide, which what it means is these are called the tails, okay? So each of those are the tails. Okay, your tails. So the tails of your graph, if they come closer to the x-axis, when they're closer to the x-axis, pushing down here, that means it's compressing. So wider means it's closer to x-axis. Okay, closer to the x-axis. Whereas this one is not close to the x-axis. It's further away from the x-axis. How come? It's not compressing upwards. It's getting skinnier and compressing down. So these ones are always they're stretching, sorry, not compressing. These ones are stretched down, okay? Or they could stretch up. You could have one that looked like this. You could have a guy that looked like this, same kind of thing, where he did this, and he stretched upwards. Okay, just similarly over here, this one could be coming downwards. And they can be anywhere on the graph, it doesn't matter. What we're talking about is how close they are to the x-axis, basically. So, wide ones are far away from or close to the x-axis. The skinny ones, the vertical stretches, they are away from the x-axis. Okay? B, what does B do? This one is called your horizontal stretch. Okay, it's your horizontal stretch. So that means how far left and right did the graph move from 0? So how far left or right did the graph move from the center, the origin, 0, 0? Okay, so how far did it move from that center? Did it go left or did it go right? So, again, little mini picture. I could have a graph doing this. Whereas my original graph, I'm always comparing everything to. I compare everything to my original graph, which would be this guy. It touches 0 and goes straight up. Okay? And then you have the negative version, which is the mirror image right underneath it. I'm going to put the mirror image underneath it. So this mirror image goes underneath, same thing. Okay? That's our basic one. That's what we compare everything to. How come? Because it goes through 0, 0. Its x-intercepts and y-intercepts are 0. So the equation is y equals x squared positive and y equals negative x squared. The positive goes up, the negative goes down. That is what it tells you with the tails. Okay? So we compare everything to this one. What happened to this graph? What did it do? Which way did it move? From 0. Where'd that red move? It moved left. Good. It also moved down, which is what we're going to talk about in C. Okay? So this guy here, he moved left. Okay? That guy moved left there. And that will be the horizontal translation. Now, in dash 1, they have to find out how to calculate that. We don't calculate that. The only ones we calculate are A and C. Okay? They will give us the B numbers. Okay. On letter C. What does letter C do? Well, we know C is the constant. Okay? C stands for the name constant. Okay? Whoops. Constant. Which means there's no variable. And what do we know about the constant in any equation? It's a location on the graph. What is it? Always, always, always. Okay. So, the constant is the same thing as saying the y-intercept. Which means that's where it touches the y on the y-axis. Okay? So if I have an example of y equals 3x squared plus 2x minus 9, if I want to know where that graph touches the x-axis, I would draw myself a little mini graph, sketch it. First thing I look for is, okay, is A positive or negative? He's positive. He's positive, so that tells me he's going up. Where does he touch the y-axis? -9. So I already know 2 spots. I know -9 is where he's going to touch, and then I just draw my graph because it's going up. Okay, that's what it tells me about the graph. It's going to touch -9. Okay, that's the job of the constant, to tell you where it touches that y-axis. Okay, on the next one, we're going to graph some of these graphs and see what we are. This one here, this guy here is our basic. Okay, this is our basic quad graph that we compare everything to. And this is the other basic one. They're identical, only one has a hidden positive one, the other one has a hidden negative one. Okay? So everybody put those into your y equals, and we're going to see what happened to those. Okay? So if we take a look, I'm going to hit my y equals, and I'm going to type in x, and then hit this x squared button on beside the comma there. That's your x squared. Okay? Right now, if you have a different window from our last unit, hit zoom 6. Zoom 6 will take you to a 10 by 10 graph. There is your basic equation. Okay, and that's what it looks like. Okay? Now we're going to type in, after we draw it, make sure everybody draws it, okay? So draw it on here. So we're going to draw our basic graph right there. Okay, that's what you should have drawn for him. The negative one. Okay, let's take a look at the negative. We're now going to go back to our y equals, and we're going to type in negative. Now don't put the blue button in. Don't put any of those buttons in. Those aren't negative buttons. That's a subtract sign. You use the negative one beside the enter. So negative x squared. Okay, and hit graph. It's identical, only it's going downwards. So it is the mirror image of what just happened. Okay? So draw that graph, please. Now we need to put the other 2 graphs in. So x squared plus 2x plus 1, if we factored that guy, we know it would be x plus 1 and x plus 1, right? If we factored it. So it should be x plus 1 and x plus 1 in brackets, if that's what I have. So this would be x plus 1 equals 0. That's what it would be if we actually graphed it. Okay? But we're not going to graph it. Or sorry, if we factored it. We're going to graph it instead. So go to your y equals, clear what's in there, and type in x squared plus 2x plus 1. Okay, and then hit graph. Now we're going to see what happens to that graph. What number do you think it touches? Kind of what?
-1.
-1. Look where it is on the graph here. It moves left, right? It's touching -1 down here. So how many x-intercepts does it have? 1. So this guy would have how many solutions? 1 solution. Okay? All right. So now we're going to say this guy's like this. And what number should he touch on the y-axis here? What number does he touch? +1. This guy right here. That's where he touches on that graph. Okay? And he touches down here at -1. Okay? That's what that graph does. Don't forget to put arrows on the top. Now we're going to put the next one in. Is there a constant on this one? No. So it's like +0. It's going to go right through that middle. That's where it's going to touch. Okay, so everybody type that one in. We're going to see what happens to that one. All right. Back on. Put my y equals. Clear it out. -x² plus 2x. Oh, I have a 3, so I have a negative. Thank you. Negative. There we are. Okay, and that's where that guy goes. Whoa. So if we draw this one, this guy's going to go through 0, and then he comes back down. So he went through 0 there. Okay, that's the 0, meaning the y-intercept. He can touch the y-line except for at 0. Now, what number did he touch over here? What number do you think he touched over there? +2. Good. Now, why is that? Well, let's take a look. If we factored that, let's try and factor that. We've got -x² plus 2x. Remember, we always want x in front here to be positive. So what would I divide out first? A -x. I divide out a -x. So I'd have -x bracket. Negative divided by a negative is a +1. Positive divided by a negative is a -2. That's what's left over. Well, what do you know? This guy would give us an answer of what for a solution? Where's that guy give us an answer for a solution? From last unit. Nope, the guy would just be x over here. 0, because there's a hidden -1 beside that x. Remember, everything has to equal to 0. You just don't see my equals 0 at the end here. This guy, if we take him out of brackets, what does he equal? +2. Now let's take a look at where he touches my x. He touches at 0 and +2. Okay, so we're finding the same things from graphing that we did last chapter, okay, or last unit. So let's take a look and see. What patterns do we notice? What patterns are you noticing? There should be a big one right away that you noticed.
Most they're all touching 0. Well, not all of them.
Okay, hang on, I'll just put this one up here for you so you can see it. No, this one back up here so you can see it. Okay, so what did you notice about all those? What pattern do you see? Okay, up, down, up, down. That's a very good observation. What do you notice about why it does, though? Thank you. So if we take a look up here, the pattern we see is everything with a negative is going down. Okay, the negatives are going down. That's what we're seeing. Okay, so we have negatives point down. Okay, that's one of the big things we saw. What else are they? What else do we notice? What about the shape of our graph? What kind of shape do we have? It's like a U, okay, and like a hill, right? We have a hill and a U. So the shape is like this, down like a hill, or it's up like a U. Those are the shapes. Well, we know what that shape's called. It's got a special name, the shape does. It's a parabola. It's spelled parabola. So it's a parabola. It's a parabola. That's what the shape is called. Whenever you see that hill or that U, you're looking at a parabola shape. Okay? What else is shaped like a parabola? A pierogi. All right. Here we go. Yeah, it was. It's on there. Okay. We're going to graph this guy right here. Here's graphing x squared. So if I graph x squared right here, okay, I want to graph x squared, but I'm going to graph according to what I see here. Okay? So, when we graph negative x, that means I go left on x to -3, and then positive 9. Now I'm going to go up 9, and I'm going to see where they meet. Okay? Where they meet, I make my point. Okay? That's how you make points on the graph, if you didn't know how before. Yep, that's how you do it. And then you just erase those lines. Okay? There's your first point. Okay? Then we go to negative 2 and 4. So we go over negative 2 up to 4 and see where they meet. That's where they meet. Okay? Graph your grid, please. Negative 1, positive 1. And 0, 0. 1 and 1. 2 and 4. And then we've got 3 and 9. Okay. So if we join our dots, we're going to have a parabola. Okay, there's our basic graph. Now, what do you notice about the numbers on the right-hand side and the left-hand side? What do you notice about those numbers? What do you notice about the numbers? They're the same but opposite, right? So basically, it's a number and it's opposite. A number and it's opposite. So negative 3, positive 3. Negative 2, positive 2. Negative 1, positive 1. Same with the y's. 9, 9 on the bottom. 4, 4 on the bottom. 1, 1, and 0. So the numbers are always reversing. How come? Because it's changing directions. That's why. It's starting up here, coming down, whoa, 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 hits 0 and goes, I'm going to change directions. I'm going to go back up. Okay? So that's the change of direction part when it hits 0, 0. Okay, that's your change of direction. Okay, the change of your direction is also known as your minimum or maximum point. Okay, so change of direction is the min or maximum point. That's where they always change directions. So if it was going the other way, I would have something doing this. That means it starts down here, goes up, 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 changes directions, and comes back down. Okay, just like the questions we saw last unit. Okay, now we're going to graph some more. What if they don't give us the y numbers? How do we do it if we don't give it, if we're not given the y numbers, but we're only given x? That's right. We would just put this equation into our calculator. Now just wait, hold on. Okay, there's a couple ways to do it. One way is to throw them into y equals, graph it, and then try and solve where all those are. Because what you can do is, when we want to know the y number, but don't have x, we go second trace value, which is number 1. So that's one way to do it. Okay, so second trace value, which is number 1. Okay. Now when that comes up, you're going to get a cursor at the bottom that says x equals, and it's going to blank. Well, that's where you put one of these x numbers in it and then hit enter. When you do that, it's going to tell you the y number when that x number is there. Okay? No, you won't do that. So what you're going to do next, you could also do it a different way. You could store x in your calculator or just substitute it into the equation. Okay? Now maybe I just suck at substituting. Maybe I'm not very good at it. I get my negatives and positives all mixed up. So I need to put it in my calculator. So this is what we're going to do. Grab your handy-dandy calculators. We're going to turn it on, and we're going to open up our y equals. Okay, let's put our new equation in. So we've got negative x squared plus 2x, now we have a plus 7 on the end. Okay, we're going to hit graph. All right. Now we want to do the second trace feature. I want to know what the y number is when x is 3. So I'm going to go second trace, number 1, value of x, there's my x blinking. So I want to know y when x is negative 3. So I put negative 3, enter. Whoa, whoa, whoa. Back that up, that's not what I'm supposed to put in. Negative 3, good, enter. And now it's going to tell you the number there. And it's a coordinate point. So now I know that when it's negative 3, the y number is negative 8. Okay? And we do the exact same thing for each one of them. So now what you're going to do, is you're going to do it all over again. You're going to hit second trace, number 1, so just enter. Now you put in negative 2, enter. You got negative 1. Okay, so negative 2 gave you negative 1. Okay, I want you guys to fill out the rest of the table of values, please. Okay, we've got our table of values filled out. You're going to notice the constant in the equation is the same as the y-intercept when x is 0 in the table of values. We're graphing every point now. -3, -8 is down here. -2 to -1 is right there. I almost messed that up. Then we've got -1 and +4. So -1, +4. Then we've got 0 and 7. Then we've got a 1 and an 8. Then we've got 2 and 7. Then we've got 3 and 4. 4 and -1. 5 and -8. Now, what do you notice about the distance between the points on the graph? They're the same distance away from 0. So if you take a look, right here, those guys are directly right across from each other. Those guys are directly right across from each other. Those guys are directly right across from each other. Okay? That's how we form these graphs. Let's look at another example. All right, now we're going to write down what these characteristics actually mean. So, the vertex of a parabola is always its highest or lowest point. Okay, that's our vertex. So, we call this the min or max point. Okay, so it is the x and y value of the min max point. It's the x, y values of the min or max point. And that's what it's telling us here. Your vertex must be a minimum or a maximum. So here's my generic graph grid. Let's draw a couple graphs. Now we're just going to draw any normal one. We can have this guy going down and this one going up. Okay. Up here, our vertex. Down here, our vertex. Okay, there's our vertex. How do you know if it's a min or a max? Which way it's pointing. That's exactly right. So if you take a look, this one here, this is a maximum. How come? If we take a look at what's actually going on with the graph, I'm starting low, I'm getting up here, I'm going higher, but that's as high as I can go. I can't go any higher than that. Then I turn around and go back down. So that means that it's the maximum height I can go is there, and then I have to be below it. Okay? So it's up to that vertex point, the maximum, then it's got to be below. Over here, this guy here is a minimum, because that's as low as he goes, and then he changes directions and goes back up. Okay? Now, if you take a look at number 3 says, the axis of symmetry intersects the parabola at the vertex. So basically what it's telling you, and it says the parabola is symmetrical about the line. That's a whole bunch of fancy words to say the axis of symmetry cuts your graph in half as a mirror image. So, at the vertex. So I'll make a dotted line at the vertex. That graph, don't mind my drawing, I can't draw very well, it's not balanced, but it should be identical size on both sides of that line. Okay? That's what it's telling you. So if I chop that graph in half right along that line, I'd be able to fold it over and it would cover completely. It would coincide with the other side. Okay, so it's going to be a mirror image. Same thing over here. If I cut it down the middle line, again, you're going to have a mirror image if you cut it down. Okay, that's what it's telling you. Let's take a look at the rest of the features. So it says when the coefficient of x squared is positive. Okay, so that means the a value. The coefficient of x squared, that's our a value in front of x. Okay, sorry, our a value in front of our x squared. When it's positive, it's going to go up. Okay, and then when it's going up, that means this. Okay, that's where a is positive. It's going up. Okay, then its vertex is going to be a minimum. Because it's right here, that is my minimum point that it can go down. It can't go any lower because it changes directions and goes back up. Then we do the opposite. Because when the coefficient of x squared is negative, so when my a value is negative, I have this. So that's a is negative. It's going to go down, and then it's going to have a maximum point. Okay, so it goes down, and it has a max point. The maximum point it can reach, and then it has to turn directions and go down the other way. Okay, the next we have domain and range. Domain of a quadratic function is called all possible x values. So you want all possible x values, okay? Now, when we say it's all possible values of x, we would say it's called x such that x is any real number. That's how we would write it. This funky line here means such that. So we would write it as x such that XER. X is any real number. And that's set builder notation. So domain always talks about x. Domain and x go together. So then range and who goes together? Range and y. Good. Range and y. So the range is dependent though. Okay, the range is dependent. What's it dependent on? The minimum or maximum height. How come? Because range deals with our y values, which go up and down. So this is how we would write the range. I'm going to write it down here because I'm running out of room. My range will be written this way. If it's got one of these, okay, and up, the range, because I've got a minimum value, is going to look this way. Y such that. Y has to be every number bigger than, bigger than your minimum here. So bigger than or touching that minimum value. Okay? So your minimum. And then comma, YER. 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 Here's the next kind. So that's one range. That's the range that's going up. So the range is different if it's going down. So if it's going down, and we've got a max value, our range is this. Range is this. Y such that. Y then must be lower than or touching the maximum value. And then YER. Again, that's set builder notation. Okay, good question. What happens if we have XER? Is it always XER for domain? Well, domain and range change the minute it's problem solving. Then we get boundaries. How come? Because if we look at our normal grid, we know that this is positive, positive, negative, positive, negative, negative, positive, negative. Problem solving, we only ever deal with positive values. So this first quadrant, that's called our problem solving quadrant. So then we're going to have some boundaries, which means on our range, we only go as low as 0 and then higher. So then it's going to look different. Then it's going to say x and y are between these two numbers. Okay, that's what it's going to look like. X and y are between two numbers. Okay, and that comes up a little bit later in our problem solving. This is called analyzing your quadratic. When we analyze quadratics, we need to analyze every single part of it. Okay, and some of it we don't even have to put it in our calculator to analyze it. We know it right just from the equation, especially because it's in general form. So, right now, direction of opening, we're going to look at our A. Okay, look at your A number in front of x squared. If it is a positive in front of x squared, what direction is it going to go? Up. If it's a negative in front of x squared, what's it going to do? Down. Good. So this guy's going to go up because there's a positive in front of x squared there. And this guy's negative, he's going to go down. Okay? Vertex we can't find yet because we need our calculators for that. We can automatically go down, though, to our domain. What does domain always have to be if it's not problem solving? XER, good. So x such that, XER, funky brackets. And then I'll just put same here. Okay, it's the same as that. Have your little curvy brackets around it. Those are called braces, actually.
I just got my time, so I don't think it will.
Okay, so now we're going to take a look. It says minimum or maximum point. Remember, we know that already by whether or not it's going up or down. If it's going to go up, do I have a min or max point? A minimum point. So this guy here is going to have a minimum point because he's going up. The one over there, because he's going down, is going to have a maximum point. Okay? So that tells us something about our range right away. We can set our range up like this. Well, if it's minimum, we've always got y such that. Okay, that funky line there. It's always a bigger, longer line. And now we're going to say y. Now, if it's a minimum, okay, the y has to be going which way? Up or down? It's got to be everything above, right? So we're going to say greater than or equal to. And then now we got to wait for that number because we don't know that number yet. And then we go comma y-er. We know all about that. The one on the right-hand side is going to be identical, except for the part right here. This part right here is going to be backwards. So this one now is going to go y such that y is less than or equal to the other number, comma y-er. Okay, so we know those things automatically about our equation. There's one more thing we can figure out about our equation before we put it in the calculator. The y-intercept. Which value is that? A, B, or C? It's C. Good. So everybody find your C numbers in the equation. If we look up here, our C number right here is what? -3. So I would say my y-intercept is 0, -3. Because remember, it's a coordinate point on a graph. You have to put it as a coordinate point. X is always 0 on that line. Over here, what do we have for a y-intercept? And 0 and +7. Excellent. At this point now we go to our graph. There's only one thing we have to find out. Vertex. Vertex is going to help us fill in our range. And it's going to help us fill in our axis of symmetry. Then we find x-intercepts. We already know how to find x-intercepts. So I'm going to leave you to yourself for about 30 seconds to find the x-intercepts. Then we'll do vertex together. Okay, so find the x-intercepts on both equations, please. Okay, so the x-intercepts are something you found already. X-intercept on here. Again, just like our y-intercept, we're going to write it as a coordinate point. So we have an x number, and then y is 0. We have an x number, y is 0. What are those x numbers that it touched on? Okay, so we've got -3 and -1. It's positive. Oh, it's +1? Pardon me, thank you very much. Nope. Okay, x-intercepts on the second one. What'd you get? And what else? 2.1, comma 0. Perfect. There's our x-intercepts. Now we have our tricky part here. Now we're going to find our vertex. The vertex will tell us this, and it will tell us the number we need for our range. Okay, it's going to tell us two things. So how do we do it? That's where we're going to go min-max. So again, we're in second trace. Everything's in second trace. So on your calculator, we're going to go second trace. Now, because it's going up, I've got a minimum. I'm going to hit number 3. Now on these ones, when you've got minimum or maximum, you've got to be to the left of the hump or the hill, and then to the right of the hump or the hill before you can guess. So right now my cursor's on the right. I have to move it with my left arrow to the left. Okay, anywhere on the left, hit enter, go to the right, hit enter 2 times. Okay, now -0.99 repeating, just put a -1 is fine. So this will be at -1 and -4. So I'm going to write it down now. I've got, whoa, I knew what I just did there. Okay, so I'm going to have negative, what was it again?
1.
Okay, -1, -4. Okay. Now, -1 and -4, I've been given x and y numbers. They're each x and y, correct? X comes first, then y. Well, our axis of symmetry is the x number up here. So what do I say? And we always want to write it as an equation. So we say x equals -1. How come? Because that's where I can chop the graph in half and flip it over on itself for a mirror image. That's what it's asking for. Now we're going to do the same thing on the right-hand side. Okay, so take your calculator again, go to your y equals and put the other equation in. Insert a negative sign there, and then we have what? A +7? +7. Okay, so there's my new graph. I need to find second trace. It's going to be a maximum. Okay, how come it's maximum? Because it's got a top number. It's going up, or sorry, it's going down, but the hump is at the top. So I'm at the left of the hump, enter. Now you're going to go to the right of the hump, enter 2 times. And I'm going to get 0.999, which is basically 1. So we're going to put 1, 8. Okay? Whenever something repeats like that, just round to the next digit. Oh, then maybe I put a wrong equation. Let me check my equation. It's the same as what you guys. Oh, it's different than you guys, that's why. There's 2 in front of there, so I have to insert 2. Oh, it's -2. Back it up. -2. There we go. That's better. So, second trace, forward, enter, go to the right, enter 2 times. There we go. So, 0.499, so that'd be 0.5 and 7.5. So I write it down as coordinate pair again.
It's +x.
It's +x. What did I have in there? I have 2x. I'd still use the other equation. My goodness. Okay, back to my y equals. Delete the 2. All right, now I've got the right equation. There we go. Enter. Enter 2 times. Okay, there we go. Now we're cooking. So 0.25 and 7.125. Now this one you're going to notice is 3 digits, but it's an exact 3 digits. It doesn't round up. We're going to actually use all 3 digits because it's an exact value. So we've got 0.25, comma, 7.125. That was my maximum point. So now my axis of symmetry, I go over here and I use my x number. And I say, okay, well that's x equals what number? 0.25, good. Okay, because that number comes down here. Okay, this number comes down here. Now, the y number of our vertex, that's the number that goes in our box in our range. Okay, that box I drew in our range here, that's where this y number goes now. So now I'm going to take my y number, this guy right here, my -4, that's going to go to my range. So I put -4 there. This guy here, he goes to my range. So I'm going to put 7.125. Okay? And that's where we find everything to analyze quadratics. We have had a couple minutes to work on these last couple questions. So let's identify everything that you have analyzed here. So your intercepts, again, write them as coordinate points. So your y-intercept, always the c value. You've got 0 and 20. Why isn't it 20, 0? Because that would be an x-intercept. We want y-intercept where x is 0. Your x-intercept is always going to have an x value and y is 0. We find it's going to be -5 and 0 and 2 and 0. All right. Our vertex gives us a -1.5 and 24.5. Now again, remember those numbers are going to be helpful for us for our equation of axis of symmetry and our range. Okay. The domain, we can always fill that in first. Where do you get your domain? We know that it is funky brackets, there's your braces, x such that x can be any real number. All right, back to our axis of symmetry. Which one is it? Hopefully you all chose x. Just remember, axis of symmetry, what letter does it have in there, x or y? It's got the x in there. So that's a good way to remember that it's the x number that you need. So again, we write it as an equation because that's where you would chop your graph in half, where you have a mirror image. So our equation of symmetry for axis of symmetry is x equals -1.5. All right, our range, it is the y value in our function here. So if we take a look, the range, we have to first of all decide, is it going up or is it going down? Hopefully you all realize it's going down. When you put it in your calculators, you would have seen something that come down like this. Okay? touched at positive 20, and there's our x-intercepts, okay? Now, since it's going down, we've got a max value, so that's going to change our range, meaning it's going to be y such that y must be less than or touching, so less than or equal to our maximum point, 24.5, comma, again, y-e-r. Okay, that's how we write our range. And now that is a total analysis of your function here. Take a look, check your work, and make sure you got it right. Okay, you got a couple times to look at this question as well. So here we go. Your intercepts. Starting with the y from the equation, we get 0, -6. The x-intercepts are going to be -3 and 0, and 1 and 0. Coordinates of my min or my max. Again, that's my vertex. So in this case, the min-max, don't forget, that is the vertex. This is going to give me -1 and -8. Now my equation of symmetry, I'm going to use my -1. So x equals -1. Domain, always. X such that x can be any real number. There's no boundaries on x. Range. All right, the range, we do have a boundary. Now what kind is this? This one's going up, so we are going to have a minimum point. Since it's a minimum point, that guy goes into our minimum. So we have y such that y must be bigger than or touching -8. And again, comma, y-e-r. And put your braces in. Okay, so the coordinates of our min-max. There's your coordinates of your min-max. That's actually your vertex as well. It's asking for our vertex. But if it's just asking for the coordinates of your min-max, I think it's talking about your the y. Usually it wants the y if it's talking about min and max. Okay, so min-max is more the y. So our vertex here would be the -1, -8. And we sketched our function. So check your work, make sure everything matches. Moving on. Now we're going to be dealing with lists of data. We're going to have to start dealing with and starting to identify, can we do scatter plots? And what the heck is a scatter plot? So how do we know if a table of values is going to look like a quadratic or whether it's going to look like something else? So what we do is we take our graph, our graphing calculator, you turn it on, and you hit the stat button. The stat button is near the left arrow at the top, and you're going to hit edit. You want to edit. How come? Because we're going to have a set of lists. Our lists are where we put our x and y values. Now, we always put list 1 is x and list 2 is y. So going back to here, I've got 0, 1, 2, 3, and 4. Now remember, after each digit you must put enter for it to go to the next line. Hit the right arrow to go to list 2 and enter every digit. 2, enter, -1.5, enter, -5, enter, -8.5, enter, and -12, enter. Now we've got our data in our lists. We want to take a look and see what kind of graph we have. So we're going to go to our scatter plot. Everybody take a look above their y equals in their calculator. You're going to see a yellow word, depending on which calculator you have, whether it's yellow or maybe it might be green or blue. This one says stat plot. This is where we get a scatter plot of our graph. Okay, so everybody hit second y equals. So second y equals. And here it's going to say typically your plots are off. What that means is I can't see the dots of my graph. I want to see the dots of my graph. So right now I'm going to hit enter. That takes me into that menu. And right now it's blinking on the on. Whenever it's black, that means you've selected it. So right now I'm going to change it to black. Now I've selected on. Down to type, that tells you what kind of graph you can actually draw. Right now I just want the dot graph so I can see what kind of graph I'm building. Then right now you can go down. Again, it tells you the X list comes from list 1, the Y list comes from list 2, and you can decide what kind you want to see on your cursor. Do you want your cursor to be a plus sign, a dot, or it could be a box? We're choosing the box just so you can see what happens here. Now that we've chosen our stat plot on, everybody hit graph. Oh, before you do that, don't forget to go to your Y equals and clear out what's in there. You're going to see that as well. So now let's go to our graph. What shape is that drawing us? It is a linear graph. It is drawing us a straight line. So I have a graph doing this. I see a straight line coming down. So if it's a straight line, is it a quadratic formula? Would it be a quadratic equation? No, this one's not a quadratic. Okay? We're going to do the exact same thing with B. Give it a try, push pause now and play when you're ready. Okay, you're going to notice when you have your graph built that we're in our normal 10 by 10 graph. That's our student 6 graph, where we've got negative 10 on the left, positive 10 on the right, negative 10 below, and positive 10 above. Right now, if you look at our Y list, do we go above the number 10? You betcha, we sure do. We actually see the number 31. So in order to see the number 31, I need to mess with my window. So I need to go to my window, and I need to check the maximum number for my window here. So we're going to go to the Y maximum. So scroll down using your down arrow. Where Y maximum is, right now it's got a positive 10. We need to change that to a number that's larger than 31. So I'm going to hit 35 so that we can at least see that. Okay? Now wherever it says X SCL and Y SCL, that's talking about the scale. What are they counting by? You can count by 5s if you want. You can count by 10s. It basically shows you all the increments on the graph. I'm going to make this one go by 5s just so you can see the difference. Okay, and I'll make the top one go by 2s. It's not necessary. By 2, not 5. Okay. Hit your graph. Now what do you notice that makes? That's starting, it looks like, to almost make a straight line, but it's got a bit of a curve in there almost. Okay, so if we actually trace that on our graphing or on our calculators, we've got a bit of a curve going on. Okay, so it's not linear, but it's not a quadratic. Okay, so it's non-linear, non-quadratic. So again, both of our tables of values, we saw the pattern of the dots, and it did not show us a quadratic. Okay, this is the end of lesson 3A, characteristics of quadratics. Now you can work on your practice booklet questions.